Hi there! In this session we're going to learn how to compute double integrals and triple integrals numerically using Matlab. There are two functions for double integral and they are integral 2 and quad 2D, and that's the quadrature two-dimensional, and these are the double integral computation methods. And there is a integral 3 which can be used to evaluate triple integrals, and they're almost the same. Let's start with the integral 2, and quad 2D is like integral 2, and they are called in a very similar way. For example, if you want to calculate the value of this integral for x equal to a to b and for y equal to c to d, the function f of x and y and differential of y and differential of x. Then you can evaluate the value of this double integral using the function integral 2 as this. You may pass the function as a function handle of two variables and then pass the lower and upper limits for the x and lower and upper limits for d and some named values after that, and we skip this for now. Remember that a and b are scalars and they are numbers, and this is a function handle, and these are either scalars or functions of x. So, for example, we can define c as a function handle with a single variable, and that variable is x. So we might define this as c of x or define this as d of x, and they are independent. One of or both or none of these limits can be scalar or function handles, and they are independent. So that's very similar to the single integral we discussed in previous session. Let's start with a simple example. For example, we have this integral of the form minus pi to 2 times pi, and that's the limits of our first variable x, and 0 to pi, and that's the limits of y, and the function is y sine of x plus x cosine of y, differential of y times differential of x. And we know that the true value of this integral will be minus pi squared, and let's calculate it with Matlab. So let's define the function. F is a function of x and y, and that's a function handle, and the terms are y times sine x plus x times cosine y. So let's define y times sine of x plus x times cosine of y. And remember from previous session, we used dotted style multiplication, division, and power functions and operators to enable the algorithm, the integration algorithm, to evaluate the function in a vectorized way. And that's it. F is defined. And now let's call the integral 2 of f, and the lower bound and upper bound for x is minus pi, 2 pi, so minus pi and 2 times pi, and 0 to pi, 0 and pi, and let's call it, and we get minus 9.8696, and if we calculate minus pi squared, we have almost the same value, and if you, for example, add pi squared to this, you'll get a value very close to 0. And the absolute tolerance and relative tolerance and other settings of the single integrals are available here too, and I left to you to check for the effect of absolute tolerance and relative tolerance in the evaluation of integral 2, and you can test it. It's very simple and straightforward. And now let's use quad 2D. It's almost the same, quad 2D. of f from minus pi to 2 pi, the limits of x, and from 0 to pi, and that's it. It's almost same, and if you add up the p squared to this, it has the same result, I think. And let's do another example with the limits of y as a function of x. So let's calculate the value of this integral. The limits of x are 0 to 1, and the limits of y are 0 to 1 minus x. So the upper bound of y is a function of x, and we must use a function handle to define this. And we're going to evaluate the value of this integral, square root of x plus y times 1 plus x plus y, all of them squared, and dy dx. And the exact value of this integral is given by pi divided by 4, pi fourth, and minus half. And that's the exact value of this integral. And let's calculate the value of integral using Matlab. So let's define g as a function of x and y, and that's 1 divided by open parentheses to define the denominator of the function. And remember that we use the dot operators here to enable the algorithms to evaluate the function values in a vectorized way. And square root of x plus y times 1 plus x plus y squared, and that's it. We have the function. And if we call integral 2 on g, and the limits of x are from 0 to 1, and from 0 to 1 minus x, from 0 to 1 minus x, and we cannot use this notation. We must define a function handle. We can define it outside of the function, and we can use the name, and we can just define it here as the variable. And that's it. If we call this, we get the value, and pi divided by 4 minus half equals to the same value. And if you calculate the value here, you'll get value very close to 0. And if you replace integral 2 with quad 2d, you'll get the same result, almost same result, and that's quite similar. And in case you'd like to define this upper limit as a function handle, you can do it by, we defined g, and we defined the y max as a function of x, 1 minus x, and you can call integral 2 of g from 0 to 1, from 0 to y max, and that's it. You can define this as a variable which contains the function handle and pass the variable name here, or you can just define it here. And you see that the Matlab works well in this case. And for triple integrals, as I mentioned before, we have integral 3 function, and that's almost the same. Let's do a simple example and finish this session. We are going to calculate the value of this integral. The limits of x are 0 to pi, the limits of y are 0 to 1, and the limits of z, our third variable, is minus 1 to 1, and the function is y sine of x plus z cosine of x, and dz, dy, and dx. And the exact value of this is 2. And if we'd like to calculate the value of this, we call the integral 3 function as this. Integral 3 function. We define this as f, and we pass these limits 0 to pi, 0 to 1, and minus 1 to 1, and other named parameters. And remember that, like integral 2, these are scalars, and these are scalars or functions of x, and these are scalars or functions of x and y. And you can use what you need to calculate the value of integral, and that's almost same as the integral 2. Okay, let's calculate the value of this integral. Let's define the h as a function of x, y, and z, and the value is y sine of x plus z times cosine of x. So y times sine of x plus z times cosine of x. And we have the function. We named it as h, but it's the same. And let's call the integral 3 of this function h. And the values 0 to pi, 0 to pi, and 0 to 1, and minus 1 to 1. And if we evaluate the value integral, we get this value. And if we compute the error, that's almost 0, very close to 0. And by this simple example, we finish this session, and we've learned that integral 2, quad 2D, and integral 3 can be used to calculate double and triple integrals numerically using Matlab.